Welcome, I'm Bill Wake. We've been working on 10th, a programming language similar to 4th, this week on Twitch. Last week we started compiling numbers to do a push in. So we had the compiler working for building new routines basically, but we didn't have it so when you typed a number it would compile. We had it so to evaluate. And then this week we completed a lot of primaries. So dot prints things, slash times percent is mod, slash percent is div and mod, min, max, absolute, negative, all the relational operators, including comparison to zero, logical operators, and pop and swap. And we completed a control structure, repeat until. It's also one that gets happens at compile time. So I just grabbed a semi-random piece of the primaries we worked on. So the relational operators, they were also similar. We could just get by with a condition or a macro. So I made a binary rel op. It takes the name of the macro, a condition like EQ, and a description to explain what this macro is doing. And for all of them, it's basically pop two values, compare them, and set the register to either 0 or 1, depending if the condition was met, and then push the result. So pretty straightforward. And we had all 6 of those binary ones implemented with just one-liners like 35 and 36 show. Another one was mod. So ARM64 doesn't have a modulo operator built in. So we did one where you divide and multiply and subtract. So again, you pop 2 values, you do a signed division, x2 equals x0 divided by x1, and then we did msub, which is a multiply and subtract. So let's see, I think we multiply x2 by x0 and then subtract that from x1, or I may be twisted around, I have to look, but somehow we end up with the modulo value in x0, and line 70 we push that. And then dupe, it just looks at the top value on the stack and pushes another copy of it. So all straightforward. Most of these kind of arithmetic, logical, relational ones, they're all pretty close to being that simple. All right, the bulk of our time was looking at repeat until. So this is our first control structure. And the way it works is repeat is a meta word and so is until, meaning it runs even if you're just evaluating things, but it's really intended as part of a compiler when you're in compile mode. What we want to do is we want to generate certain code. So if we were writing the new code in assembly language, we'd say start is the beginning point of the thing, kind of where the repeat is. Then we have the code inside the loop. That's the ... a up above. And then we'll do a jump if false back to start. Otherwise, we'll just fall through and carry forward. Okay, so let's see how each of these pieces makes that happen. So in repeat, our goal is we're going to push the code address to a control stack. So the control stack is a compile time stack, and it's got all the nested control structures going. So I've assumed we had a couple in place, and we're doing a new repeat. And this repeat, the secondary on the right there, is address 20, which is not a realistic address, but it's handy enough for us. So the next address to write is 20. So we're going to push that address on the stack because we need it later at the bottom of at the until. So we've got to have it available. Okay, next thing we're going to do is we're going to generate the code inside the loop. And so code inside loop, more code inside loop, and that generates 2 values in the secondary, or however many there are. It could be in any number of instructions. But the key thing is they start at address 20, and there's whatever code there is put in the secondary. Finally, we get the until, and until generates the jump if false, and then it pops the control stack to get that value 20 and puts that in the code. So jump if false is defined to pop its next word, the word following it, and use that address, either jumping back if it's false or just falling forward if it's not. All right, and then we compile whatever the code is after the loop. That about does it. I mean, it's kind of the easiest control structure. We haven't done if for a while, but they'll have similarities, but they'll be a little trickier. All right, so the key code for this is really in these two routines. The first on the top right is the repeat. We're just pushing secondary space, which is what points to the next available location, and we're pushing that onto the control stack. And then the until, it has to write the jump if false, and it stores that in the secondary. So that's the first line of this. And then the second one is it pops the control stack and writes that address over to the secondary. So what's on the control stack is the address to jump back to. And that's really all there is to it. It's pretty straightforward. All right, except we tried our nested repeat until, and it seemed not to work, or well, it did not work. It started generating like -1, -2, -3 when it was supposed to only deal with positive numbers. The loop is a little complicated looking, but if you spread it out over a few lines to format it, you'd probably make sense more easily. But I wanted to do something like print 54321 or 54321 4321 321 and so on. And so you push a 5 on the stack, you subtract 1, you print it, you subtract 1, and so on. So this code doesn't seem to work. We tried a number of variations. They all seem to have problems. So the first question is, like, where's the problem? Well, it could really be in three places. Our high-level code could be wrong. Our translation might be wrong. So the code we just went to write the jump if false and keep track of the address and all that, that could be wrong. Or the interpreter could be interpreting jump if false wrong, or maybe some other things, but that's probably the most likely. And jump if false, it checks popped. It pops the value, checks it for 0. If it is, it loads the virtual PC with the contents of the virtual PC, which is pointing to that address. Or it skips it, in which case it just adds 8, and so it skips over the X1000, etc. Any of these could be wrong. We, unfortunately, spent about an hour trying to do it through is number 3 wrong or is number 2 wrong? And it's tricky because once you've compiled these secondaries, it's kind of hard to look at them and know exactly what you have because they're all pointing to addresses that contain function addresses. And so there's a little indirection you have to track through and so on. So it's a little tricky there. Checking the interpreter, my fear was maybe the virtual PC was not pointing to the next address, but was pointing to the address it was executing instead, jump if false. And that turned out to be working fine. It was pointing where it should. So it turned out, surprise, the 10th code was wrong. So I tried a different one. :foo defines a word, and semicolon on the end. But the core of it, 5 repeat, print. So starts with 5, prints that, duplicates the value, and then repeats with that 5 in the inner loop, which subtracts 1, prints it, duplicates it. So we get 4, duplicate it, get 4. Bang is not, like C, and 4 is not true. So we got a false until, checks if it's false, jumps back to the innermost repeat, and so on. This code works. The other didn't. What the other one did wrong was it got to a point where it would, because it was subtracting 1 from the main value, like 5 repeat dot 1 minus there, subtracting that. Well, it would get to 0, which was fine on terminating the outer loop, except the inner loop then started with 0, subtracted 1, and started repeating until it hit 0, which it wouldn't do for a long time until the numbers wrapped around or something. I was only willing to wait, for a couple 100,000 to print. It's very fast. In a way, that's good. I've got a lot more practice writing assembly than I do in writing this 10th language code at this point. We realized we really don't have any debugging tools for ourselves in this new language, and we might do a trick or two to allow us to make that running easier or debugging easier. All right, now next week, we're going to finish up remaining stack operations. So we have CAB, which pushes, swaps the third entry on the stack to the front, CBA, which sort of Well, it sort of reverses the top three entries, I guess you'd say, or you could look at it as swapping the first two entries and then doing the rotate again. And then BAB, which duplicates the second but also leaves it there. So I don't think it'll take long to do those. Then we got to do if else and while do statements. I know those will be a little tricky, but hopefully not too bad. And then we got to work out some language features. We haven't supported variables, arrays, or strings yet. Variables, we're mostly using the stack, so we don't need explicitly named things, but at some point we will. Arrays and strings require a little more work for us to think through, but I think I've got enough of a scheme to make them work. And if we get that far, we'll give it a go. See if we can get those in. All right, so you can join us Monday through Thursday, just Wednesday next week, 2 to 4:30 Eastern Time or 6 to 8:30 p.m. UTC. It's at xp123.com/Twitch for the live ones, or xp123.com/YouTube is for the old sessions, time delayed, about 3 weeks maybe, and lightly edited. All right, thanks. Hope to see you sometime. Bye-bye.